Hi, everyone. This is for Math 10C, and we are doing the unit Relations and Functions. We're doing Lesson 5, Slope. So we're on page 22 in the note package if you have the whole note package. If you're doing a lesson from the Google Classroom, it's excerpted. Okay, so Lesson 5. So we're looking at slope. Now, when we talk about the slope of a line, and you probably heard that term, you've heard phrases that refer to slope, things like, oh, whoa, that's very steep, or, oh, that's not a very steep or climb, or I wouldn't want to roll down that hill because of what the slope is. So we're talking about basically the steepness of a line, okay? So that's basically what slope refers to. It refers to the steepness of a line. So looking at this, we want to look at these 4 lines, and we want to talk about their steepness. So we want to arrange the line segments shown in order of steepness from least steep to the steepest. So looking at this, when we're calculating slope, we often talk about slope as being the rise, so how much it goes up over the run. So looking at the first line, if we look at how the rise over the run, the rise is 3 and the run is 2. So it goes up 3 for every 2 units it goes over. So its slope would be 3 over 2, which would be 1.5. The second line, it goes over 3 and goes up 3. So it would be 3 over 3, which is equal to 1. The third line, for every 1 it goes over, it goes up 4. So it would go up 4 over 1, which is equal to 4. And the last line goes over 2 and up 4. So it goes 4 over 2, which would be 2. So if we were arranging this in terms of steepness, so it's from least steep to most steep. Well, looking at that, the line segment that is the least steep would be CD, because it has the smallest number, 1. Then would be AB, because it's the next largest number, which is 1.5. Then we would have GH, which is the next, which is 2. And then finally, we would have EF, which is the most steep at 4. The steepness of a line can be determined, as I've said, by looking at the ratio of the change in the vertical values, or the rise, to the change in the horizontal values, which is the run. In math, we call this steepness slope, so I'm going to talk about slope a lot. And we use the following formulas to help us calculate it. And I did that up there on those graphs. The slope is equal to the rise over run. Or we can talk about it in terms of rate of change. So the change in y, remember the y is our vertical and our change in x is our horizontal. Or we can write it as m is the slope, is equal to the change in y. Triangle means change in. Let me rewrite that so it looks prettier. The triangle means change in. So that's what that means. So, and m is our variable that we use for slope. So if you see m, we're talking about slope. Okay, so let's move on. determining the slope of a line segment. So for each of these, we want to determine the slope of a line segment. So we're going to use that formula. So m, the slope, is equal to the rise over run, which is the same as the change in y over the change in x. Okay. Now, looking at the change in y, it goes from here, it is at -3 all the way up to +3. So the change in y, it changes from -3 to +3, so it is equal to 6. And the change in x, it goes from -6 to 4. So -6 to 4 is 10. Now we have 6 over 10. That's a fraction. It is not in lowest terms. We can leave it as a fraction, but we should put this in lowest terms. So if we would reduce this to lowest terms, it would be 3 over 5 would be our slope. Okay. This next one, so we want it's our change in y over our change in x. Our change in y, it starts at 4 and goes down to -6. So it's important to note that it actually is a negative value because it is going down. So 4 to -6 is a change of -10. And for our x, it goes from -3 to +2. So it is a change of 5. So our slope would be -2. So just make sure you note that for a slope that goes down, we're going to get a negative slope, not a negative slope, negative slope, because it goes down. Okay. Now, next one, let's take a look at this. M is equal to change in y over change in x. So it's going up, so we're going to have a positive slope. We know that. For y, it goes from -5 all the way up to +4. So the change is 9. And for x, it goes from -5 to 1. So the change in x is 6. So our slope is 3 over 2. And then for our last one, m is the change in y over the change in x. So looking at our change in y, and this one is going down, so we're going to have a negative slope. It starts at 2 and it goes down to -1. So the change in y is -3. Change in x, it starts at -4 and goes up to 5. So the change in x is 9. So again, we want to put it in lowest terms. I can divide a 3 out of the top and the bottom. So it'll be -1 over 3. Now, it's important to note that we've taken the entire line segment. You can also take slope just from a section of the line if it goes through a point. And it doesn't matter which point you start with. If you start with the end or the beginning, you should still get the same value for slope. Now, there are 4 types of slope that you're going to see in Math 10. So the first one here, we have the line segment going up to the right. So from left to right, it's going up. Both rise and run are positive, so we get a positive slope. So think about this like you're climbing a hill. That would be a positive slope. So the run is positive and the rise is positive. Now, the second type, the line segment goes down to the right. The rise is negative because the y starts higher than it ends, and the run is positive. The slope would then be negative. So think going down a hill. Okay. Now we also have some other kinds of slope. We might have a slope in Math 10 where we have a nice horizontal line segment. So what we notice with this is the y doesn't change. Y is always the same. So the the rise is 0 and the run is positive. So no matter what x is, y is always the same. So for this, the slope is equal to 0 over the run, whatever that run might be. If it's 5, if it's 10, if it's a line with an arrow on both sides, then it's infinity, but it would be a slope of 0. So there is no vertical change. And then the last one is if we have a vertical line segment. So in this one, the run is 0, the x value doesn't change, and the rise is positive. So there is a difference between in your y values. So here, if we figure out our calculation, the slope is rise over 0. So everybody try that. It's like with fractions where we talk about can't have a 0 on the bottom, because when you divide that on your calculator, anything divided by 0 is going to be undefined. So there is no horizontal change, and we have an undefined slope. And if you're ever not sure, just put in your calculator, and you'll notice that your calculator will say error because you've got an undefined slope. Okay? But if you memorize these samples of slopes, you should be pretty good. Okay, moving on. Drawing a line segment with a given slope. So sometimes you're going to be given a slope and a point, and it's going to ask you to draw a line segment. So what you simply do is you start at the point. So start at the point, -1, -1. So let's start there. So that's going to be here. And then it's telling you the slope. The slope is 7 over 5. So it rises 7 for the run of 5. So you're going to go up 7 and then go over, or go to the right 5. So let's just count that. So we're at our point. We're going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then we're going to go over to the right 5. 1, 2, 3, 4, 5. Now, we can connect those. Now this line would keep going. You could also go down 7. 1, 2, 3, 4, 5, 6, 7, and go to the left 5. And what we notice if we do that, we have a continuous straight line. Now this line would have errors on both sides because there's no ending points given. So you could also go down 7 and go left 5. But remember, they're in pairs, okay? So you're either going up 7 and going right 5, or you're going down 7 and going left 5. Can't mix those up. Okay, let's look at the next one. Actually, why don't you try the next one? So if you want to press pause, try it, and then come back. Okay, so for this one here, we're going to, we're at our m is equal to 3/8 at point P -6. So we start at P -6, 0. So that's our starting point. So my x is -6. 1, 2, 3, 4, 5, 6, and we're at 0. So it's right here. Make sure I count that right. Okay. Now, according to our rules, we're going to, our slope is a negative. Always think of that negative being with, it's easier if you think about it being with the y. So we're going to go down, because we're going -3, and then we're going to go right 8. And again, you can do the opposites, going up 3 and left 8, but I'm going to go down and right. Okay, so I go down 3, 1, 2, 3, and I go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And those would give me my 2 points. Now, hopefully you have a ruler or a straight edge. I'm just eyeballing it because when I do it on my iPad, it kind of shifts everything. But if I were doing this on paper, I would use a ruler. Okay. Let's look at the next one. Hopefully we got that right. So for this one, we have our point -5, 0. Our slope, I would keep the negative with the 8. So go down 8 and go right 3. Okay, so let's plot our point, -5, 1, 2, 3, 4, 5, 0. And I'm going to go down 8. 1, 2, 4, 5, 6, 7, 8. And I'm going to go right 3. 1, 2, 3. So this would be my point. And then I connect those. And again, hopefully you have a straight edge at home. And the only reason I'm not doing it is because it does shift my iPad and it makes it look funny. So hopefully we got those correct. It's pretty straightforward. It's a nice tactile activity. Now, sometimes we're given the points on a line, and it's nice we can do the counting to figure out our run, but we also can use the following formula to calculate slope. And this formula is on your formula sheet. You'll start using that more often. I think it's in your resources. If it's not, I'll double check. But this is a formula that you'll be familiar with. So instead of doing the counting, what we can do is we can simply substitute in. So looking at our equation, if we have 2 points on a line, A and B, we can take the values for y and x on those points and substitute them into this formula and calculate. Okay, so because we don't always have the drawing, this formula can work for us. So let's take a look at this first one here. We have C, -5, -3, and D, 2, -1. So this would be the same as C would be x1, y1, and D would be x2, y2. So we're just going to take this formula for slope. Slope is m, which is y2 minus y1 over x2 minus x1. And we're going to substitute in. So from this, y2 is equal to 1, and y1 is equal to -3, and x2 is equal to 2, and x1 is equal to -5. Now, remember your integer skills. Minus a negative becomes plus a positive. Makes that a lot easier. So our slope would be 1 plus 3, which is 4, over 2 plus 5, which is 7. So instead of sketching that line and doing the counting, you can use this formula to figure out the slope of that line if you're given 2 points. So here's another one. So again, x1 and y1, x2 and y2. So we're going to substitute that in. So y2 minus y1 over x2 minus x1. And here's a secret. It doesn't matter which of those 2 points you make as being the first point, which one is the second. You'll get the same slope regardless. Okay, so I just made those ones, y1 and x1, but it doesn't matter which one you do. Okay, so y2 is 6 minus y1 is -5. And on the bottom, x2 is 8 minus 4. Now, remember our integer rules. Minus the negative becomes plus a positive. And then we get m is equal to, well, we have 6 plus 5, which is 11. And 8 minus 4 is 4. Now, when we're talking about slope, yes, that is we look at it, it is a improper fraction. For the purposes of slope, you're probably better to leave it as an improper fraction instead of changing it to a mixed number. It's just going to be easier because you're going to think about in terms of counting units on your grid. So for right now, don't worry about changing them. Now we can apply slope. So let's talk about applications of slope. Slope is also known as a rate of change. So as one thing is changing at a certain rate, another thing is also changing. Okay. More specifically, the rate of change is referring to the rate of change in the dependent variable, so the y value, with respect to the change of the independent variable. Okay. So the rate of change in y based on or with respect to the change in x. Typically, the rate of change has a specific context, so units are used for the slope. When we're talking about real world situations, they would have a context. They would mean something. It would be distance versus time, or money versus hours, or products, or number. So they would have a context, and this is where the real world application comes in. So let's look at example number 4. Identify the independent and independent variables. Determine the rate of change of each relation and describe what it represents. So for each of these, A water tank on a farm near Swift Current, Saskatchewan, holds 6,000 liters. Graph A represents the tank being filled at a constant rate. So if we look at here, graph A is filling the water tank. We have our time and our volume. So looking at this, our independent variable because that's the first thing it wants us to tell it, would be the time in minutes. And our dependent variable would be the volume in liters, okay? And then it wants us to determine the rate of change and describe what it represents. So the rate of change, basically what we're looking at is the slope of that line. So it's going to be the 6,000. If we look, it goes from on the top, the change in y over the change in x for our slope would be the same as the change in volume over the change in time. So it changes from 0 to 6,000, so 6,000 liters in 120 minutes. And if we calculate that, that's 50 liters per minute. So this means that the tank is being filled at a rate of 50 liters for every minute. So that would be if we're expressing this in words, okay? All right, that's what that represents. So let's look at the second one here. This graph shows the fuel consumption of a scooter with a full tank of gas at the beginning of the journey. So someone's out in a scooter, he's got a full tank of gas, and he rides it till it is empty. So let's take a look. First, it wants our independent and dependent variables. The independent variable is going to be the distance, how far he travels. The dependent variable would be the volume, how much is left. So if we look, we've got our distance down here, volume up there for so it's how much we're going to have left after we drive. So then it wants our rate of change, or same thing, slope. So it's going to be our change in dependent over the change in independent. Another way of expressing it. So if I look at the beginning, I start with 8 liters and I go down to nothing. So I have a negative on top, negative 8 liters, because that's the change. And I've changed from 0 to 200 kilometers. So 200 kilometers. So this means I have, if I simplify this, I can divide both the top and the bottom by 8, and I'll get negative 1 over 25 kilometers. And that would be my rate of change. Now, explain what that means. Well, that means that the scooter consumes 1 liter of gas for every 25 kilometers it drives. So if we wanted to explain that, we'd write the scooter consumes 1 liter of gas for every 25 kilometers it drives. Okay. Alrighty, so that's slope. Great introduction to slope. Your homework is to do page 325, 1 to 5, 8A, B, and 10, and then try out the practice test on page 335. Remember, there are keys, answer keys at the back of the textbook, so you can check your work. So please do that to make sure you're doing them right. And then if you have any questions, email your teacher to ask. Once you've completed this one, go on to the next lesson, which is lesson 6, and have a good day. Bye.